Jumping right into full screen problems on these trapezoids because you only really encounter two problem types. Find the missing angle, find the area. It's easiest just to work these on a full screen ACT example. And I want to talk about these angle ones first. We're going to do both in this video. So on these angle questions, what they're usually actually testing is your knowledge of parallel lines or supplementary angles, or both. And there's usually a couple ways to do these. So let's take a look. So we got a trapezoid here. Trapezoids, by definition, have two sets of parallel bases. So these guys have to be parallel, otherwise it's not a trapezoid. Obviously it's not these two, right? We're going to use that information to help us find this angle, but let's take a look at what else we've got here. We got this master angle, this whole corner marked up. We got part of this one, we got this whole corner marked up. So we got some missing stuff here, we got a missing thing here. And we're looking for angle ACB. ACB. So then we're looking for this guy. I'm going to draw a really small question mark. Okay. All right. So this is a pretty common setup here. What we have here is this trapezoid has been cut into two triangles, or there's a transversal going through two sets, or excuse me, going through our set of parallel lines. So one way to start this that's most obvious, now there's a lot of ways to go, and some are more direct than others, but I'm going to try to go the way I think would naturally occur to you, is to find the angles as best we can. So look, I see this triangle, I've got two of the three angles. This third angle will be 180 minus 50, it's 130, minus 24, 106. So this angle here is 106. All right, now what? Well, kind of stuck, right? What do we know? What do we know? Well, we're going to have to bring in our knowledge of parallel lines. If these lines are parallel, right? And I'm going to try to sketch a couple parallel lines down here. Not terrible. Remember, corresponding angles dictates that this angle, right, and this angle are equal, and these little angles are equal to each other as well. That's going to be the case here. So this 24 angle sits on this side. So up here, this angle has to be 24. And if you're fuzzy on that, check out the stuff on angles. So we know now this angle, this angle, this angle, this angle, this angle. The only angle we're missing is our last little question mark angle. So now we can subtract from 360. Trapezoids are four-sided shapes, so they sum to 360. Just make sure I get all my angles in there. Believe it or not, that's a pretty common mistake. 106 minus 50. Okay, so that's quite a lot of subtraction. Let's go ahead and do that real quick. And I get 21 as my missing angle. And that makes sense. Okay, so A is my answer that way. There's a shorter way to actually do these problems. I want to show you that real quick. So I'm going to back out all this stuff. Erase all this stuff. Now this usually works on these problems, but not always. It depends on how the problem is set up. I'll leave my parallel lines. So let's get back to our transversals, right? Except in this case, we're not looking at this diagonal across the trapezoid. We're looking at this side right here. So if I have something like this, and these lines are parallel, remember, right? Well, this angle and the small angle are supplementary. They add to 180 degrees. Okay? Well, I've got two of the three components already, right? I've got 135 and 24. So the quick way around this is 180 minus 135 minus 24 degrees is 21 degrees as well. So a couple ways to do this. Sometimes you can end up with a third way to solve these as well, but you know, it's not dissimilar from finding the missing angle of a triangle or problems like that. It's a combination of that and using parallel lines, supplementary angles, corresponding angles. That's all there is on this area stuff. Let's flip over to, that's all there is on this angle stuff. Let's flip over to the area question. Okay, here's our trapezoid area question. It's a pretty standard setup. There's at least 3 ways to do this, and let's take a look at them. Now, you could use the trapezoid area formula, and that's the average of the bases times the height will equal your area. Well, and your bases, of course, are the parallel sides. Height, of course, is perpendicular, as it always is, in slanty side shapes, which is not a real term, just my term. So the average of the bases will be 5 plus 11 divided by 2. That's 16 over 2 is 8. So 8 times height is 4. So our area would be 32. 8 times 4 is 32. That's one way to do it. Now, you can remember that formula if you want. If it's easy for you to remember or you already know it, go for it. Great. Perfect. But these aren't that common a question. And if you see one, you're really only going to see one of them. So I'm not a huge fan of you going the extra step of memorizing it. Because the way these are presented, there's usually a few ways to go about it. So let's look at a second way. Let's break it into shapes. And they're nice enough to do that already. Even if I didn't have these lines here, I could still do this to some extent, as long as I knew the size of this base, right? So I know that this rectangle in the middle is 5 times 4 is 20, length times width. Now, I don't know what the bases of these triangles are. I really don't, because it could, even though they looks like this one's kind of bigger, but, I don't really know how that breaks down. It actually doesn't matter. I can even pick numbers for the sides as long as they add up to the difference of 11 and 5, right? These triangles together are going to have a base that's 11 minus 5. Both of these triangles' bases added together will be 6. So I could pick numbers, I guess, if I wanted. Or I could think about it this way. Let's pretend that this rectangle isn't here for a second. By rectangle. And we push these triangles together. Okay? Then I'd have a triangle that kind of look like this, right? With a known base of 6 and a known height of 4. I can solve it using that. So area of a triangle is 1/2 base times height. So area of this triangle would be 1/2 6 times 4. So 6 times 4 is 24. Half of that is 12. So my middle, if you recall, was 20. Even though I got rid of the rectangle for the demonstration and putting the triangles together, I still need to use it for the area, right? And then the area of my two triangles is 12, and that also gets me to 32. That's a way I really like, frankly. Third way to do this is using our friend the Pythagorean Theorem, and it gets kind of messy. But it's very doable, and for a lot of people, it's the one that occurs to them. So you find the area of this rectangle is 20. This is a right triangle. This is a right triangle, and it has another leg of 4. So using the Pythagorean Theorem, you could figure out what the respective bases of these were and go from there. Not my favorite way to do it, but it works. So 3 ways to do this. They're usually going to give you a lot of options. If you want to remember the formula, great, but you could also treat this like a combo shapes problem. All you need to do to be able to do that is the size of this top base, which they're going to have to give you anyway, even if you're supposed to use the formula, because you needed to average the bases together. So as long as you have that and the height, which are 2 integral elements that you'd have to have anyway, you could split this into shapes. Okay, that's all I have on trapezoids. Because this is like combo shapes, I'd really check that out as well. Combo shapes are very, very common on the test. When I say combo shape, it's my phrasing. I just mean when you have like a circle in a rectangle, or excuse me, a circle in a square, a rectangle in a circle, triangles in circles or squares, or you get the idea. So check that stuff out. It's really helpful.